So first of all, thanks a lot for having me. It's great to be here. It's my first time in Russia. Thanks for making it to the session. So today, I'm going to talk about measuring and predicting systemic risk. Now, a little caveat. Some of you might have noticed I'm a bit different from other people. So I'm a statistician and econometrician, so my research is a little bit more kind of focused on quantitative finance. So what I decided to talk about is to kind of give a survey of the current literature of systemic risk measurement. Now, this literature, as I will explain through my presentation, is quite heterogeneous. I'm focusing on a small subset. And I'm also going to talk about some of the research that I had the luck to kind of contribute to that has appeared over the last couple of years. So let me begin and let me set the stage. I think it's fair to say that the concept of systemic risk has emerged prominently in the aftermath of the financial crisis. I think it is fair to say that something that in a way got lots of people surprised, at least in my field, in the aftermath of the crisis, the following thing. We had lots of extremely cool and developed risk tools that would allow us to monitor the individual risk of individual institutions. But in a way, we totally failed to measure the degree of risk that was building up in the entire financial system. So this has prompted a lot of guys to start developing tools to carry out to develop methodologies to carry out effective systemic risk measurement in the financial system. This literature is quite big. It's quite big. The financial crisis motivated a lot of efforts, not just in academia, to try to come up with accurate measures of systemic risk for the economy. There are also new agencies and new jobs that now you can apply to that before the financial crisis didn't exist. So for instance, now in the US, you have the OFR, the Office of Financial Research, which is an agency which is essentially devoted to the measurement of systemic risk. In Europe, you have the European Systemic Risk Board. I have some anecdotes. I know the people working there, for instance, these guys produce each month a booklet with over 400 systemic risk indicators, and they have to do this by European law because apparently European Member of Parliaments each month like to check what is the level of the indices of systemic risk that are produced by these guys. I don't know whether that's happened, but there's legislation in place for the production of these indices. And as I was pointing out, the number of contributions in this literature is really broad. However, the literature, I would say, it's still kind of young. The approaches are very heterogeneous, and if you ask me, it's not really clear if we have a single best approach that so far everyone agrees it's the best to use. However, we do have some approaches that kind of work well, and now we're working kind of hard in back testing, also using historical data, some of the proposals that have been made in the aftermath of the financial crisis to see what are the kind of methodologies that are really useful to use. Now, before I talk about how to carry out systemic risk measurement, let me talk a little bit about what systemic risk is. Again, there are lots of different heterogeneous definitions of systemic risk out there. What I'm going to do here a little bit, I'm going to do a principal component analysis and extract the two elements that, in my view, tend to be recurrent in all the definition of systemic risk that you have out there. So, systemic risk is often defined as the risk of an event that can essentially halt the correct function of the entire financial system. And this event is so extreme that can generate negative externalities to the rest of the economy. Okay, then we can then decline these kind of 2 points in very different ways, and you can get the definition of systemic risk that different kind of big guys in the literature have put forward. But I like to think that these two elements really are kind of common in, I would say, 99% of the definitions of a systemic risk out there. Now, let me point out a couple of things just to try to make clarity over this kind of broad definition. First thing that you may ask is systemic risk a different type of risk that didn't exist before and now all of a sudden we have? So is systemic risk orthogonal to other types of risk that we know and we have studied through the years, like credit risk, market risk, operational risk, etc.? So, in my view, systemic risk is absolutely not orthogonal to these already existing types of risk. In a way, what qualifies a risk as systemic is the fact that it is so extreme that it can halt the correct functioning of the financial system. So, you could have a credit risk, you could have a credit event which is so large that essentially is going to destroy the financial system. So let me make an example. Default risk is something that credit risk manages. The failure of a bank, if happens in normal times, doesn't constitute any major concern. But if, let's say, 51% of the financial system defaulted on the same day, then that would be a problem. So that would be an instance of systemic risk. Okay, so in a way, systemic risk is you can think of it as a linear combination of existing types of risk out there. It's just an event which is so extreme that it might kind of wipe out the entire financial system. Another thing that I want to point out is that which I'm emphasizing also in the slide a little bit, is that typically when you read the literature on systemic risk, you always have this kind of reference to the negative externalities that this systemic event is going to have. And I just want to comment a little bit more about that. Typically, finance offers emphasize a lot that, systemic risk has to have real consequences. If it's something that's just confined to that is disruptive, but it's just confined to the financial system, but this will not qualify as a systemic event. What's the rationale of this? Now, many industries can experience distress, okay? However, the idea here, this is something the finance profession believes, I would say, is that the financial system provides the plumbing of the economy. And if the plumbing doesn't work, you cannot live in the house anymore. So a halt of the financial system will essentially make it impossible for the normal business to go as usual. This is important because, in a way, this justifies the reason why we have special regulation for financial firms and for a systemic crisis in the financial system, but we don't have the same type of regulation for other sectors, okay? We could debate about this, okay, because maybe saying that only financial system is systemic, it's something that, not every one of us might agree with. For instance, I could claim that maybe the automobile industry in the US is systemic. In fact, at the end of the 2000s, some big automobile companies were bailed out because essentially were too big to fail, if you ask me, okay? So we could debate about this. But I think the mainstream finance point of view is that essentially it's the financial system that has this kind of fundamental plumbing functionality for the economy, which makes it important for systemic regulation to be in place. We know typically the US doesn't like a lot of regulation, so if you have some regulation in place, you better be well motivated. Now, what do we want to measure? Again, a lot of heterogeneity out there. But in the end, I think it is fair to say that you have two things that we would really like to have and that everyone really try to strive for. The first thing that we would like to have is that we would like to have an index that measures the aggregate systemic risk in the economy. And what we would really like to have, but unfortunately this is hard, is that we would like to have an index that can give us some kind of early warning signals of distress in the financial system. What supervisor would like to have is a tool that tells them, look, 6 months from now, things might be a little bit gloomy, so that we can try to act to mitigate or eventually to avoid the whole financial crisis. The second ingredient that people want, the second product that people are trying to construct are measurements of the systemic risk contribution or the systemic risk vulnerability of individual institutions. In a way, one of the things we learn in the crisis is the idiosyncratic distress of individual firms that really kind of caused the whole system to go down. So the new regulation that we have in place in the aftermath of the financial crisis states that there are some institutions which are deemed systemic, then depending on with different declinations, okay. And if you recognize a systemic institution, then we have special regulation for you, okay. So there are different type of criteria that people have put forward. For instance, the BIS has a number of has essentially kind of a bucket list approach to kind of identify which institution are systemic or not. On the academic side, what people have done is that they have tried to develop methodology which allows to come up with criteria to identify when an institution is systemic or not. These are the two objects we'll try to put our hands on. So how are we going to do it? Now, in this set of slides, I'm going to focus on a subset of systemic risk measurement contribution that focused on using market data to measure systemic risk. And again, I would say that this is an important subset of the literature out there. I think most of the academic contributions, at least in economics and finance, live in this world. However, there are also other type of research. So for instance, people coming from complex sciences are using interbank lending data, which unfortunately, however, is proprietary, and they use interbank lending data between banks to simulate what happens if one bank fails, and they use that to construct systemic risk measures. Unfortunately, I would say that in economic finance, this kind of data sets haven't been studied so much, and most of the research follows essentially is based on analyzing essentially stock prices and try to infer the systemic risk, the systemic riskness, so to speak, of the institution, of the entire system on the basis of stock prices. Now, when you talk about stock prices, well, people sometimes have mixed feelings about it, so let me just try to motivate things a little bit more here. So, if you believe the efficient market hypothesis, stock prices reflect all publicly available information regarding a company. So the idea here is that we would like to try to build up an index of systemic risk that tries to squeeze the information which is implied by the action of market participants. The pros of this type of approach, I would say, if you'd ask me, is that, well, if you ask me, typically market prices react quite rapidly to news. They're available at very high frequency so that we can carry out systemic risk monitoring in real time. And they are widely available. Essentially, most banks that you would like to, for which you would like to construct a systemic risk index typically have stock market data available. So this makes using stock prices quite appealing. Of course, sometimes, well, I think it is fair to say that, sometimes people point out, well, markets are not always efficient. So when you're looking at stock prices, sometimes you have the doubt that where you're looking does not really reflect fundamentals. And to be honest, I agree with that. However, let me say that even if when stock market prices don't really reflect fundamentals, to me it's still interesting to understand what the market thinks. I think, if you have that caveat in mind, that when you're looking at a stock market implied systemic risk measures, you're just looking essentially at what market participants believe, and what they believe sometimes might be wrong. Once you just know that caveat, to me it's still kind of an interesting object to look at, because market participants, I would say, are not the most stupid people out there. I mean, if they were very stupid, they would not have a job. So now, this is a bit of a map between of the systemic risk measures that we have out there. So I'm differentiating between two categories of systemic risk indices. I'm very unmodestly citing myself here. We have capital shortage measures, which in a way are kind of the new thing that came out in the aftermath of the crisis. So this, in a way, are kind of the new products, the new approaches for measuring systemic risk in the economy that became popular in the aftermath of the financial crisis. Then there's another literature which is a little bit somehow more traditional, that focuses on measuring systemic risk, essentially by looking at contagion and spillover measures between financial institutions. This is something that has been around for a long time, to study contagion and interdependence, not just in banks, but also in countries and so forth. And this has been done in 20 gazillion ways. I'm not going to talk so much about this because we don't have the time. I'm going to essentially focus the presentation on these two things. These are actually papers that have recently been published. So this just went on American Economic Review, and the paper by Achari, myself, and Engo just got published on the Review of Financial Studies. But actually, these papers have been around for a very long time. We just suffered a lot in the revision process. These guys, I have to say, they're a bit sneaky. I mean, I'm exaggerating here, but basically, Adrian and Bernard Mario had a working paper on something called CoVaR, which was totally unrelated to the financial crisis, that came out in the summer of 2008. Then the events of the crisis unfolded. Tobias Adrian is at IMF now, but he used to be an economist at the New York Fed. So essentially, as the events of the crisis were unfolding, these guys, just modified the paper, which turned out to be perfectly suited for the financial crisis. So in a way, they kind of got a lot of street cred earlier on, just because, essentially, this was a very good idea, but actually it was just being introduced to conferences on risk as the Lehman bankruptcy was happening. The other risk I'm going to talk about is S-risk, just to clarify how things work a little bit here. So essentially, Achari and co-authors develop a model for systemic risk that in my opinion, kind of allows you to think, offers a nice way to, way to think about systemic risk. I'll give you more details later. And what my advisor at the time and I did, we just try essentially to make try to transform the intuition of the model something that you could work in practice. What happened is that, again, so these guys had a working paper coming out pretty much at the same time of the crisis. I moved and started my postdoc essentially 1 week before Lehman failed. So sometimes my advisor thought it was my fault if Lehman failed. I said correlation is not causation, but I have to say that in this case, I would make an exception. So he decided to make me work on it just to try to redeem myself for the mess I've done. As I was saying, what's in a way peculiar about these two indices, and that's in a way the new thing that emerged in the aftermath of the crisis, is that these kind of indices try to measure the capital shortage that financial firms are going to experience, the capital shortage that financial firms are going to induce in the rest of the system. So let me explain a little bit more here. So many things happen during the crisis. One of the things that happen is that one of the things that we learn is that when financial firms lose a lot of capital, then the financial system is going to be capitally constrained, and the financial system is not going to stop functioning properly. Then the capital shortage of a financial firm can be resolved in a number of ways. So the firm could go bust, or the firm could be bailed out, or the firm could be bought by another firm. But if the capital losses suffered by these financial institutions are substantial, none of these three avenues is actually going to be a nice outcome. So if the firm if a capitally constrained firm goes bust, then the failure of that bank may generate negative externalities to the rest of the system. In a way, when Lehman failed, we saw what happened afterwards. The market panicked. Bailing out Lehman would have not been necessarily a better thing. Well, actually, the amount of money that the Fed would have to give to Lehman would have not a lot of money. But let's say in general, like just rescuing the financial system by using taxpayer money is not necessarily a good thing. What happened in Spain, for instance, that the Spanish government was recently well capitalized, but in the aftermath of some of the financial troubles that some of the Spanish banks had, essentially the bailout of the Spanish banking system carried out by the Spanish government made the Spanish sovereign quite vulnerable. So again, that's not necessarily a good outcome. And also what we observed during the crisis that, typically in a crisis, financial institutions basically pretty much capital shortages are kind of widespread around the financial system. So in normal times, if a financial firm is capitally constrained, somebody else will try to take over. But during a financial crisis, that's going to be more rare because everyone is going to be a little bit concerned on what's going to happen. So what CoVaR and Estres try to do in different ways is that they try to come up with an index which tries to measure what's the undercapitalization that the financial system is going to suffer as a whole, which is, in a way, I'm using cause, but here you shouldn't think cause in a causal way, that is generated, let's say, by the distress of one individual institution. And I think that, so I'm going to talk about Estres because people then, well, you and myself have worked a lot on it, but I think it's fair to say that CoVaR is probably one of the measures that these days is probably one of the most famous systemic risk measures that gets used out there. Also because people in the Fed were extremely sympathetic to CoVaR because it was proposed by one of their own, and typically when you go around and talk about systemic risk, CoVaR will be the first buzzword that people would pop up. Contagion and spillover measure, I'm not going to talk much about them. Essentially all you do here, which is kind of classic type of contagion analysis in a way, you have a big panel of financial institutions and you try to see, for instance, if you have that the distress of some financial institution, Granger causes the distress of other financial institutions. Those institutions that Granger cause more distress are typically classified as more systemic. Okay, so then you can do this in gazillions of ways. So you can do this focusing on the tail of the distribution, on the credit risk, on the market risk. So people got crazy on doing this in all different types of sources. But ultimately, this literature kind of relies on standard kind of contagion analysis that has been around for a long time. And as I said, I'm not going to talk too much about this. Now, let me talk about CoVaR. So let me start giving you some definitions. CoVaR is based on the analysis of this kind of two slightly strange return series if you come from financial analysis. So the variables that we're going to work on when we work with CoVaR are the asset growth rates of individual firms. So RIT in this section denotes the asset growth rate from one day to the next, say, for firm I, okay? And the asset growth rates of the entire market that I'm just going to denote by M. Actually, by entire market here, I'm saying I mean the entire financial system. Now, little thing, I don't want to nag right away, but little thing I just want to clarify. I mean, it would be great to measure asset growth rates in real time. In practice, you can't because you can think of assets as the sum of debt and equity. We can use stock prices to measure the value of equity of a firm on a daily basis, but debt, it's published essentially on a quarterly basis. And it's not really clear how you can measure debt on a higher frequency. So the Adrian and Brunel-Meyer analysis focuses on the analysis of these kind of growth rates. The way they put their hands on it is that they essentially define assets as the sum of the book value of debt and the market value of equity, okay? So, the methodology that they kind of build up focuses on looking at the properties of these specific type of growth rates, okay? I'm giving you this caveat right away because since debt changes on a quarterly basis and market value changes on a daily basis, when you define asset returns this way, essentially what you're really measuring are equity returns. So these are really equity returns in disguise, but in the way they presented the methodology, you should really think as asset returns. If in practice, they're not, okay? The Adrian and Brunel-Meyer approach builds up a systemic risk by looking at the properties of this series. Now, before talking about CoVaR, let me remind you what VAR is. Intuitively, CoVaR is something that builds up on top of VAR. That's actually a good guess. So let me remind you first what VAR is, and then I'll give you the definition of CoVaR. VAR is one of the mostly widely used index of systemic risk, one of the most widely used risk measures used in the industry for measuring the risk of a portfolio. Value at risk means literally the value that you have at risk when you have a risk investment. It is formally defined as the maximum loss that you expect to suffer with 1 minus p confidence over a specified horizon. Typically, for regulation purposes, this is 10 days. Here, for simplicity, I'm just looking at the daily VAR, okay? Now, let me say what the VAR is in a different way. Essentially, the VAR, you can think of it simply as a quantile of the return distribution. The only difference between the VAR of a given magnitude and a quantile is that the only difference between the VAR and a quantile is essentially the VAR is the quantile with a minus in the front. Value at risk is a loss, so losses are always positive. The maximum loss that you're going to, essentially the maximum loss of an investment with 1 minus p confidence is essentially going to correspond to the p% quantile, which is going to be a negative number. Since the value at risk has to be positive, we just multiply by -1, okay? But anyway, if that bothers you, ignore it. You can think of the value at risk simply as a quantile, as a tail quantile of the conditional return distribution that tells you what's kind of the most extreme outcome that you're going to experience with some degree of confidence. And as I said, this is used a lot, and it's used to compute capital requirements of financial institutions. Now, how does the CoVaR work? So, Adrian and Brunel-Meyer's idea, which is kind of nice, is the following. So, they look at the asset growth rates of the entire economy, the entire financial system. And they look at the CoVaR of the entire financial system conditional on some event. I'm denoting this event by CRIT. Now, CRIT denotes some event to be defined that depends on what's going to happen to firm I. So the CoVaR tells you what is the value at risk of the entire system that you expect to see if you conditional something specific has happened to firm I. So let me say this in yet another way. As I said, the VAR represents the maximum loss that you're going to experience with 1 minus p confidence. The CoVaR measures the maximum asset reduction of the entire financial system that you're going to experience with a certain degree of confidence if you condition on the fact that something has happened to firm I. And guess what? We're going to be interested in conditioning on some kind of bad event happening to firm I. So in a way, what we're asking here is that, what's my value at risk if something terrible happens to firm I? So the idea is that we believe that firm I is systemic. So we believe that when something bad happens to firm I, the whole thing is going to go bust. So the way we measure it is that we try to look at the tails of the market return distribution, conditional on this kind of state of the world in which extremely bad things are going to happen to firm I. Okay? Now, this is how the Adrian and Bruno and Mario introduced the CoVaR index, and I need to give you details if you wanted to make this operational. Okay, so I'm using the same notation. Let me add a little bit more material to see how they actually do things in practice. So we could define our systemic triggering event in a lot of ways. The way they do it, and to be honest, this is motivated essentially by numerical convenience. When we'll get to the estimation, if you write things this way, things are going to be easy, so that's why we're doing it this way. But they define the kind of triggering event for firm I as the event firm I has experiences a return which is equal to its value at risk with the minus in the front. So I'm asking myself in a way, what is the CoVaR of the entire financial system when firm I experiences a day in which it suffers a very large loss? That is, a large equal to its value at risk at some degree of confidence. If you computed the CoVaR condition on a specific choice of your systemic event, you're going to get some numerical value of the CoVaR, but this number is not really on a scale which is kind of easy to interpret. Okay, so we need to kind of standardize things in a way that we make them easy to interpret. In particular, in order to get a number which is easy to interpret, it would be nice to compare the CoVaR when there is a systemic event happening to firm I with respect to the CoVaR when nothing happens. Okay, so the way, and this is in a way the final index that Adrian and Bruno and Mario propose is the delta CoVaR. So actually when people talk about CoVaR, what they mean really is kind of the delta CoVaR. Delta CoVaR of firm I is defined as the difference between two CoVaRs. The CoVaR of the market condition on firm I being at its value at risk minus the CoVaR of the market conditional on the returns on the firm being at its median asset growth level. This in practice is very close to zero. So this is essentially very close to just simply the unconditional quantile of the market return, but however, that's how it's defined. So, I mean, this is entirely predictive. This is entirely predictive, so you should not give any sort of causal interpretation to this whatsoever. But the idea is that, this delta CoVaR measures the difference, in a way measures the increase in the tail risk of the entire financial system when you know that something bad happened to firm I in comparison to the median states of the world in which we don't consider as particularly risky. A couple of things which maybe, I think some of them I've pointed out. Let me check because I don't remember what I said, didn't say. So, in a way, what CoVaR does, in a way, this is kind of a leitmotif of the whole literature, is that we're trying to construct a correlation index in the end. But what we're trying to do here is that we're really trying to measure the dependence that we observe in the tails, in the extreme states of the world. Because somehow the assumption is that this kind of tail correlation that emerge in these more extreme states of the world are the ones that are kind of more important for us for systemic risk measurement. Thing that I wanted to point out is that the CoVaR framework, if you want, is a little bit more general than what I said. So Adrian and Bruno and Mario play with different kind of flavors of this methodology. So so far I've talked about how the market reacts to distress to one specific institutions, but you can also, for instance, look at what's the CoVaR of one firm given distress of some other firm, so you can play with it. In practice, they didn't do it too much, but in a way the framework is a little bit more general. And this point I kind of pointed out earlier. typically, the CoVaR is defined using asset returns. And in a way, that's what you may care about, because you actually want to see what's the maximum reduction in assets of the entire financial system when something bad happens to one institution. In practice, it's very hard to measure asset returns. So when you look at all CoVaR, what you're really looking at are equity returns. In fact, to be entirely honest, in the first version of the draft, they use asset returns, and in the refereeing process, somebody suggested that that's not what you should do, and so in the later version of the paper, they just focus on equity returns, and they really downplay this asset return interpretation. Okay? But originally, that's how the methodology was imagined. Last thing I wanted to point out, so this is the point about the equity returns I was making. Now, and here I'm kind of quoting, so this index of systemic risk makes a lot of sense if you're dealing with financial firms that roughly have the same size. But what happened empirically is that when you brought this to the data, what would happen sometimes is that you would end up having small firms that would have very kind of high CoVaR, and it wasn't really clear how to think of that, because I would say that small firms are typically not people do not think of small firms are systemic, I would say. And so in order to correct that, in the later version of the paper, Adrian and Browne introduced a different version of the CoVaR index, which is called the dollar CoVaR index. And what they do is that they multiply this number by the market value of equity. And the way they sell it is that if you're comparing different firms that more or less have the same size, then this is the index that you may want to look, because you're making a comparison about institutions that are roughly the same size. If you have strong size heterogeneity in a financial system, which you do have, then what you want to do is that you want to multiply this by a proxy of size. So they use market value of equity. It's not really clear what you do what you measure when you multiply by size, but in practice it works. It's kind of a bad answer if you ask me, but in practice it gives much better results when you do it. So I think when you look at rankings of CoVaR these days, typically people would look at CoVaR times market size, which is known as dollar CoVaR. Okay, so how you put your hands on this object. So there are different types of estimation approaches that people have put forward in the literature. And in particular, because let me emphasize that in a way, the CoVaR index is just some index of tail dependence that can be computed once you know how the tails of the distribution of the market returns look like. Okay? And you can do gazillions types of estimation approaches to try to estimate precisely these things. In the CoVaR paper, what Adrian and Browne do is that they propose a fairly straightforward estimation approach for CoVaR, which is based on quantile regression. And they put forward two types of methodology. One is called static, one is called dynamic. So the static just doesn't take into account in a way of time variation you might have in CoVaR. Typically, one striking feature of financial time series is that they do change a lot over time. Where they change a lot over time, I mean that they typically exhibit time-varying moments. So in the dynamic approach, what we try to do is that we try to use a little bit of a richer methodology which allows you to capture the time series variation. Well, let me emphasize that time variation, it would be something that you would care about in practice, because keep in mind that this is a methodology that we would like to run each day to monitor how things are going on a daily basis. So, since that we believe that things can change quite drastically from one day to the next, having a methodology which is able to capture that might be kind of important, not to say to some, a member of Congress, hey, look, 1 month ago, something bad happened, but our model, it took a month to understand it. So a time-varying model typically is able to react much more easily to changes that happen in the environment. So how does the estimation work? So in a way, it's very simple. If you know quantile regression, it's the easiest thing ever. If you haven't seen quantile regression, well, I'll explain. Quantile regression is really just like linear regression, but in disguise, let's say. It's a little bit more complicated, but anyway, I'll have a slide about that. So what Adrian and Browne and Mario assume is that there's a linear relationship between the bar of the market and the returns of a given financial firm I, okay? So this is a model that states the quantiles of the market are simply given by alpha plus beta, whatever returns you observe firm I. So if you're willing to assume the existence of this linear relationship between the market var and the returns of firm I, it turns out that estimating CoVaR is really easy. You just substitute the volatile risk of the market in this equation as I did here, and what you get here is the CoVaR of the market, conditional on knowing that the returns of the firm that you experience on a given day is equal to its VAR. So it's literally, super simple. The only tricky part, in a way, is that you cannot, the only tricky part here is how you estimate the alpha and betas. You cannot estimate these alpha and betas by standard regression, because this is a relationship which doesn't involve the conditional mean of the market given what happens to the returns of firm I. This is a statement that is an assumption that is made on the quantiles of the market conditional to what happens to firm I. So we need to change the estimation method, but we pretty much have to change one command in Stata or R or MATLAB, whatever package you use. So, and I'll say how that works in just a second. So the CoVaR can be computed simply by running a quantile regression to get your hands on the alpha and betas, and then you have a very simple closed form expression for CoVaR. As I said, the index of systemic risk that we like to use is delta CoVaR. Well, again, you just compute the CoVaR condition on the financial firm I being in distress. You compute the CoVaR of the market condition on the return of firm I being equal to the median. And well, if you do straightforward computation, you get this expression. Now, in practice, empirically, this is essentially 0. So I'm using this notation because that's what we use, but this is just 0. So in the end, the CoVaR index boils down to a simple product of the VAR of firm I times this beta I coefficient. This beta I coefficient, in a way, you can interpret it as a downside beta, if you will. This is kind of like the normal beta that you get from linear regression. However, here, this is not really a beta that captures dependence in the central in the central part of your distribution, but it's kind of a beta. It's not kind of. It's a beta that captures, in a way, dependence on the tails. If you live in a normal world, this guy will be a function of the linear least squares beta, the one that you get when you just estimate a linear regression. If you're willing to assume that the data is a little bit more complicated than a normal, then this thing is going to be a much more complicated function. Still going to depend on the central tendency of the data, but it's also going to depend on the tail properties. Okay, and so I'm emphasizing this quite a bit because at the end of the day, what most people do in this literature is that they really try to build up criteria that try to focus on measuring interdependence in the extreme states of the world. Because we know that when things get a bit more extreme, we experience higher and different level of dependence in comparison to what we experience in normal times. Okay, so we would like to, people think that kind of capturing this kind of tail dependence in the tails is more informative in order to carry out systemic risk rankings and to measure the overall degree of systemic risk in the economy. So this is okay, it's very straightforward. Notice this is just a static model. You just fit a regression model on the quantiles, and then you compute your fitted values. In practice, you may want to allow for time series dependence. The way they do it, it's quite straightforward. All they do is that they use a trick that sometimes people in the finance literature use, which is the following. So all they do is that they augment the regression, the quantile regression that I showed you here, using, a vector of state variables. I'm denoting them by M. So this could be some vector of, overall degree of volatility in the market, some kind of credit spread, you name it, some function, some variable that you think captures, in a way, the overall degree of risk in the financial system. And so all they do is that they just augment their regression for just state variables. And so in their application, when they look at how VAR evolves over time, since this guy changes over time, this allows you to see how the VAR of the system, the CoVaR of the system changes over time. Just one slide summary of how CoVaR regression works. So this is the kind of the shortest summaries on quantile regression I could write. It's really not that fancy. I'm not going to spend too much time on it because I don't think it's super interesting. And also it's something that it's very easy to implement. We can talk about it later if you want. So that you have y, which is your dependent variable, and x is a predictor, and you care about modeling the p% quantile of y given x, okay? And that you're willing to assume that relationship between y, the quantiles of y, and x is linear, okay? And it's linear, so in particular, you have that this conditional quantile is simply going to be equal to alpha plus bp. Notice, of course, that when you write a quantile regression model, your parameters typically depend on the quantile because different quantiles might have totally different set of coefficients, okay? So depending on the choice of p, you're going to have potentially very different coefficients here. Turns out, and that's something nice that we've been knowing since the 70s, that if you want to estimate these guys from the data consistently, you just run a regression in the end. So that's kind of nice. The only little thing is that you run a regression using a different loss function. So it turns out that you can consistently estimate these guys by minimizing this objective function. Notice that this objective function is in a way a function of the prediction error, right? Because you can think of yi minus alpha beta xi as the prediction error when you try to predict yi given alpha plus beta xi. The only twist is that, if you did a linear regression, this would be the square. If you do a quantile regression, you are, instead of computing the sum of the square errors, you are using this weird function that I'm denoted by rho p to evaluate what's the loss associated with this forecast error. And this is the definition of the rho loss functions. Note that this loss function depends on the quantile because you're going to get different estimates depending on which quantile you use. So presumably the loss function used for this evaluation is going to be, it's going to depend on p, of course. And turns out that there's this kind of very cute loss. It's called the tick loss. It's kind of a loss function in which is kind of linear, but in a way it has different slopes depending on whether you're making a positive or a negative error. Okay? And it turns out, and that was something new that people worked out in the 70s, that if you want to get, as I said, consistent estimates of this quantile, you just need to substitute the loss function used for least squares with this tick loss, and you get the estimates that you want. Again, the nice thing is that this is extremely standard to run. So, essentially in Stata, in MATLAB, in R, whatever package you use, you just have to use, instead of, linear regression command, you have to use another command for doing the quantile estimation, but it's pretty much the same thing. So let me show you the empirical evidence that you get by looking at this technology. So now, what Adrian and Mario do is the following. They look at a big sample of financial institutions in between 1986 and 2010, and they divide their banks in different groups. They have banks, broker-dealers, insurance, and real estate companies. They do the analysis on a weekly basis. Really, they do this to kind of overcome a bit the issue that they were dealing with asset returns that really were kind of equity returns, but the issue, even if you use weekly, stays there. And in the paper, they focus on the results I'm going to show you are going to focus on the results you get from the dynamic CoVaR model, which is the one that we recommend using. In the dynamic CoVaR model, you need to choose a number of variables that you believe drive the quantiles of the system. And so some of the variables that they use that are in a way are kind of the usual suspects are, for instance, the VIX, the volatility index. They have a credit spread, they have a market return, they have a liquidity spread, and then they also have the real estate market return. Now, the CoVaR paper, it's nice, it got a lot of influence. The only thing, and I'm going to talk about this more tomorrow, is that essentially we just showed kind of estimation results. We don't really have a validation exercise. This came later with other research we carried out. I'm going to show you some validation exercise tomorrow, but in the paper where we proposed the baseline methodology, essentially, they really didn't dig too much on the type of results they had, okay? So some of the evidence I'm going to show, maybe it's not entirely satisfactory, but that's because that's what they presented in the paper. Now, the first figure that they showed, they got quite excited about it. Not everyone agrees, is that they said the following thing. So some criticism people made is that CoVaR is just VAR in disguise. We already have VAR, why should we bother doing CoVaR? So what we did here, this is a picture that comes from the paper, this is a scatter plot of the bar of different financial institutions versus the delta CoVaR. And the point that we wanted to make is that, look, if you look at the scatter plot of these top US financial institutions, you would notice that essentially there's very little relationship between bar and CoVaR. The correlation is really weak. And in particular, if you start looking at some banks, you can find that, there are financial institutions that had kind of extremely large CoVaR, so you would classify them as systemic, that if you look simply at the bar, you would not think them as risky. So let me see if I can make an example like that. Perfect. So actually, that's a good example. So for instance, AIG, it's an interesting example. I think, AIG got bailed out because, the US recognized that if AIG went bust, then we would have had World War III or something. If you look at the VAR of AIG, the VAR of AIG, it's not particularly extreme. So the scale of this plot is such that the more negative this number, the more risky these firms are. So here we would see that AIG would not be particularly risky if you look at AIG on a VAR scale. However, if you looked at AIG on a delta CoVaR scale, you would see that it's the second most systemically risky financial institution. And that actually makes sense. It matches the narrative of the event we saw. Similarly, for instance, we have that Freddie. Again, Freddie, if you look at VAR, you would have not classified Freddie as a particularly risky financial institution. But if you look at the delta CoVaR ranking, this would have been the top financial institution in terms of systemic risk out there. Now, this is for the cross-sectional stuff. So this is just a scatter plot, but that's what we provide. Let me show a bit what you see from the empirical evidence from the time series perspective. So what you see here is the time series of CoVaR across time. So as I said, what people want in this literature, they want an index of systemic riskness of an individual institution and an aggregate systemic risk index for the entire system. So I've explained how to compute indices of systemic risk of individual institutions. We also want something for the entire system. So what they propose to do is that they just aggregate CoVaR across different financial firms, okay? And they do a value-weighted average, but that depends on firm size of the CoVaR individual financial institution to get an average degree of systemicness of the entire financial system. And the red line, if I'm not mistaken here, yes, this is the average CoVaR of the financial system. Now, this is nice and not nice at the same time. What's nice about it is that if you look at this picture, well, this time series plot in a way somehow matches, anecdotally at least, the time variation in the series that you would like to capture. So for instance, here we are in the 2000s, okay? This is Lehman, and the sample finishes around 2010, okay? So what do you see here is that essentially we have more extreme CoVaR, so more systemic risk in the economy, in correspondence of the dot-com bubble burst, which kind of makes sense. Then we have a period in which things get better. And now, you cannot really see it here, but I've computed for my own purposes the series separately, so I've zoomed in a little bit. If you would zoom in, you would see that essentially starting from roughly July 2007, you would see that CoVaR starts becoming more and more extreme. It makes sense in a way. July 2007 is when we first realized that something bad was going to happen. And as you can see, it picks exactly in correspondence to the Lehman events. So anecdotally, it kind of captures what it's supposed to capture. One problem, in a way, and I could get one problem, and this in a way it's a problem which is widespread in the whole systemic risk literature, is that if I flip this picture 180 degrees and I showed you a picture of the volatility during the same period, you would not be able to understand the difference. So if I get $1 for each time I had to referee a paper which had a very brand new systemic risk index that came from a totally different data set that looked exactly like the VIX, I would be rich. And that's really kind of the test you have to pass if you want to do something useful. Please tell us something that we don't know already from volatility. And it might as well be that maybe we can't do it because volatility in the end turns out to be the main determinant of, from a time series perspective, really volatility is the main driver of risk, at least the observed risk implied by market participants. It's really kind of pervasive. You can't really get it away. It's difficult to get a plot that looks different from what volatility will tell you unless you use this risk. CoVaR, I think it's a great tool. It's used a lot to monitor the degree of systemic risk of large panels of financial institutions. It's used a lot in practice. I would be a little bit concerned about how you interpret the index. You're not really capturing asset returns as you wish. You're actually just looking at equity correlations in the end. Empirically, it's driven by volatility, if you ask me, at least when you look at the aggregate. So there are a number of limitations the index has that you should keep in mind when you interpret the results that you get from this type of analysis. So if you get a systemic risk index that just look exactly like market volatility, what you're really looking at, that is not clear to me. That said, it's used a lot, especially in practice, when you use CoVaR weighted by market size to rank financial institutions. The rankings that you will get make a lot of sense and they're used a lot. They seem to be highly informative as of the development in riskiness in the financial system. And the thing that I wanted to emphasize is that besides the maybe extra step that you have to do in comparison to more traditional type analysis, which is the quantile regression step, it's extremely easy to scale this type of analysis for modeling extremely large panels of financial institutions. So what kind of nice thing, and one of the reasons why this methodology also got popular, is that traditional spillover models will be proper multivariate models. So a lot of guys publish papers in which we have applications in which they are monitoring 5, 6 banks. In practice, we want to monitor hundreds of banks. And this type of analysis allows you to do that very easily. And I'll stop here. Tomorrow I'll talk more about what I did, which is the S-risk index, but I don't want to get started with this today because it will take for me quite a bit of time to finish it all. So thanks so much, and I'm done. Now we can get questions.
So I'm interested in this because I've been looking at some value at risk things for some banks in private consulting. But an interesting issue is that how much do you think are these affected by bad data? In other words, is it robust to bad data simply because it's so correlated with overall risk, so that even bad data don't get rid of the correlation? The reason I ask is that I have a contribution to a volume on Benford's law. I was the first to use Benford's law in economics to look at macroeconomic data and its biases. And as an exercise for the special volume in Benford's law, we looked at VAR. And prior to 2008, VAR was not a common measure for the United States. And Benford's law analysis showed that VAR numbers were essentially random.
I see.
But after 2008, they lose the randomness. So they violate Benford's law strongly. So as soon as and we've done this with certain other kinds of data, as soon as they become subject to regulation, they violate Benford's law, which indicates that people are manipulating them. And so I'm wondering, given this manipulation, how does CoVaR be affected?
I see. So, okay. So, so when you apply Valat risk for when you use I would say state-of-the-art model, like Garch model, something that Rob Engel, my co-author, my former advisor, has been working on for doing Valat risk predictions. There's a big literature which emerged at the end of the 90s, which proposed different type of evaluation techniques for seeing whether your Valat risk forecasts work well or not. And I think what would be fair to say the evidence of this literature is that on daily data, these models work really well. And forecasting performance deteriorates as you increase the horizon. So essentially, I would say that at 2 months horizon, you're essentially screwed because the forecasting power of the more advanced time series model out there, or just looking at your sample quantile, is pretty much going to be the same, so you're not really getting any information from these guys. If you look at, let's say, horizon 1 to 1 month, they do work well. On macro data, it's much more tricky. So if you had an application with macro data, things get really tricky. Also because we had the great moderation, so the volatility of time series went down. But with the financial crisis, all of a sudden volatility exploded again. On daily data, you can often pick up these sudden increases because you're measuring things daily. And typically, financial crises unwrap. Even if when they're up quickly, they still are up in a couple of days, well, in a couple of weeks, let's say. On macro data at a quarterly frequency, you just go in a state in which everything is fine to a state in which you're screaming out loud and people throw themselves from the windows. So in macro data, they have poor history. On equity data, I would say that they work well, but up to 1 month, 1.5 months at most. So yeah, that would be my answer. Thanks for that, by the way.
Well, thank you very much for this presentation.
Thanks.
It's very interesting for me. And I want to know if this CoVaR gives us opportunity to find out how relevant systematic risk is for whole economy, or maybe for the part of the economy, for the financial system, for industry, or for trade system? Is it possible or is it not?
So let me see if I answer your question. So here I just give you an index, and you may like it, you may not like it. The question is it useful? And that to me is the kind of more interesting question. So there's a more recent literature which came after a couple of years later than the first working paper version of this paper, which is devoted to build up empirical assessment of these models. And what the evidence is that typically whenever these indices, CoVaR, but also other indices that try to capture essentially an increase in the distress of the financial system increase, these increase typically predict declines in real variables. So for instance, an increase in CoVaR today is going to predict a fall in unemployment and fall in GDP growth or industrial production in the US. And typically this predictability, it's significant up to, depending on the paper that you look, but it would be significant to medium-long horizons. For me, medium-long would be like 6 to 12 months. In all honesty, so the evidence is statistically significant. We're talking about kind of not super big R squares, so they help you predicting. So an increase in systemic risk typically predicts things getting worse in the future. But if you look at the magnitude of R squares, these are kind of small quantities. Problem is with the evaluation of these systemic risk indicators is that we're supposed to measure distress when the economy is in its bad states of the world. So it's not really clear what we're supposed to do when things are not bad. So my interpretation for this kind of significance, yet small R squares, is because you have a tool that is helpful if you know that something bad is going to happen. But on average, since bad things don't happen often, we don't have a lot of predictive power. So we have really predictive power when things go bad. So that's my interpretation of things.
Very nice. I have two questions. Now, one question I think is a logical one. You have this whole discussion about which kind of distributions you use. Value at risk has come under huge criticism because in many cases they use normal distributions, and of course in crisis times you will get extreme value distributions. So distributions change or condition on the environment, it seems to be, and that makes the whole theoretical grounds of these things in a way tricky, I would say in a sense. So that's my first question, how do you actually deal with these distributions, and do you use normal or something else? And the second one is on predictability indeed. So
sorry?
On the predictability, as we were just talking about. So if you look at the graphs, it seems that it's mainly good at contemporaneous estimation. So in a sense, the CoVaR, and just like the asset price itself probably, and the volatility gives the clearest indication of a problem, if the problem is there.
Yeah.
If I were a policy person, I would like to know something starts to go wrong in 2005, because then structurally things were wrong. It was an accident waiting to happen. The point is you only start to see it in July 2007, but in 2007 you have the first scandals, you have the first the hedge funds going down, you have things going in Société Générale. So we know it from also newspapers, and everybody watching the news could know actually it's going on. So my question is, don't we want more predictability? Don't you want to somehow see it earlier? And in that sense, is the stock price good enough? Because often what we see in practice is that if you have this kind of crisis, you have the boom, and then everything is inflated, and expectations are inflated, and everybody is over-optimistic, and then you get the bust. And what we want from a risk measure is also predicting things will go wrong at the moment the boom is happening, not when the boom is over, in a sense. But I don't know how to do that. It's like more of a philosophical question almost.
You nailed it. So can you remember the 2005 for tomorrow?
Yes.
Okay, so remember. Okay.
Astros does that. That's why you were smiling. I saw you smiling.
You got the year right. You got the year. 2004 would have not worked, but 2005, yes. I was right. So jokes aside, you nailed it. You nailed it. So let me say this. In a way, from my point of view, there are two aspects here. The time series prediction, that is, can we predict when crises are going to happen? And there's the cross-sectional aspect, that is, can we predict which institutions are going to suffer the biggest losses when bad things happen? Turns out, and well, I shouldn't say this, but if you ask me, what do you honestly think? I would tell you that predicting crises is extremely difficult. And if you look at the literature out there, as I would say, you find significance, you have paper published that find significance. But ultimately, if you look at the magnitude area squared, if you try to replicate these papers, you see that it's very hard to predict crisis. However, I would claim that the cross-sectional predictability is very strong. So what I claim is that if you look at the tails of the return distribution, I find these are informative to tell you which banks are going to be more sensitive to adverse market movement when a crisis hit. But absolutely, the estimates of the actual losses you're going to experience in a crisis are going to be totally off, because in a crisis they're going to be much wider. But for ranking, you just care about knowing who's the weak link, to use an expression that we used yesterday when we were miming stuff in this room. And another thing I wanted to say, so the methodology that people use, in a way, would be robust. If you had to reply to an editor, you would say, we're using robust methods which are robust we don't rely on normality and that stuff like that. But ultimately, the problem is not non-normality, it's the fact that you do not, basically there's state dependency. And what we observe in a crisis, it's, in a way, behaves totally different from what we observe in good times. And it's very hard to carry out that type of inference. But in the cross-section, there's good predictability. Just let me say this thing. There's a paper I wanted to present, but I don't think I'm going to have the time, in which we carry out a historical analysis. And what we do is the following. We have a panel of US banks from 1866 to 1933. Worst analysis I've ever done in my life, because bank returns in the 20th century are very different from what we observe today. And we compare S-risk and CoVaR, and what we see is that in the time series, predictability is low, but in the cross-section, you were able to predict which institution were going to suffer the biggest deposit withdrawals, the biggest bank runs, with 6 months in advance. After 6 months in advance, you lose predictability, but at least you got 6 months, which is, I would say, it's decent, okay? It's decent. It's hard to do better than that, I would say.
Christian, related to what you just talked about, the cross-section predictability, you say it's relatively good, but you only get the rankings. But from the policy point of view application, how it can be done in terms of what you're going to do with the most probable bank to be experiencing the systemic risk? This is the first question. The second question, probably they dealt with that in the paper, but these are publicly traded institutions, right? How do they handle, or in terms of application of this index, how do they handle the private institutions that may also have a systemic risk exposure?
So, second question, of course, that is an issue. So I wouldn't know. Like, if I don't observe it, it becomes complicated, absolutely. Typically, I would say large institutions that are deemed systemic are often publicly traded. Of course, this doesn't happen over the world. So I acknowledge that, but for instance, I would say in Europe and the US that happens. Regarding the policy implications, so 2 things. One, policy now has different rules depending if you're considered a systemic institution or not, okay? And so in a way, ranking institutions, it's important because, you decide a cutoff point, and you say if the value of this index is above, let's say 20, then you're subject to this kind of policy or not. To be honest, if you ask me how to use this stuff as well as the other stuff that has been out there, is, which I think it's honest, is as a screening device. That is, you go to the doctor, you think you have flu, you get a test. If the test is positive, it doesn't mean that you have the flu, but it means that you should do additional checks. And typically, when you do additional checks, you can really find out what's going on. These are inexpensive market-based measures that you can compute on a daily basis using yesterday's data. Actually, we have a website I might show you tomorrow in which we give you daily rankings. So I'm a regulator, and I don't want to tie my hands to CoVaR or S-risk or any other methodology out there. I look at the rankings. Whenever I see that there's a bank in my kind of watch list that I didn't previously consider, then what I can do, and I can just send people there and check whether, what's going on. Typically, markets react quite efficiently to news that affect these banks. So this could be also a criteria, which is kind of in a way or objective to say when you should send people to some bank and not to some other bank to avoid, in a way, kind of, arbitrariness in the way you monitor stuff. But if you ask me, as I said, I see this as kind of screening devices. You have hundreds of institutions. You don't want to send your people to monitor all of the banks out there. You might want to check the first 10. So which are the top 10? Okay, this methodology gives you this other methodology gives you that. Typically, there's some degree of overlap, okay? So you decide on your top, and then you send your people. So that's how I see how this stuff should be used in practice.
As you said, state dependency is the big issue, right? And one of the things I'm concerned about is it really possible to get over the interaction with macro policy, which is in some sense unpredictable? And one way to ask the question is that if you take the strong market monetarist position, that the problem was not the banking crisis was exacerbated by a Fed that did not ease enough. So if you have a kind of, let's say you look at the nominal GDP targeting guys, Christensen, Sumner, et cetera, then they would argue the problem was that Bernanke tried to, at the same time he was loosening, he was tightening by paying interest on reserves, so that's a negative signal. And in some sense, it's a breakdown in credibility that the US will maintain nominal GDP growth. And what that does is that it then causes good banks to fail, which would not have failed if monetary policy had been, in other words, kind of like, is this more like a micro prediction of the relative risks? In the sense that, imagine that you could have the same measure for, say, the tech firms prior to 2000. You would have predicted which tech firms are more vulnerable, but of course there's no macro crisis because there's enough liquidity. And so even though the size of the tech firm crash was bigger in value than the housing market crash, there was no macro risk. In contrast, because the Fed, according to market monetarists, didn't target nominal GDP and sent a negative signal in terms of unprecedented paying interest on Federal Reserves, then you get a kind of banking crisis that is made worse than you would have had if it were just a housing market.
So let me try to answer to that. So let me answer, and I'm sorry for that, but more from the point of view of this other index that I'm going to talk about tomorrow. But so what we do in this index is, and this is also what CoVaR does, but I like to think this is done more kind of explicitly in the index we develop. We give you an index of how much capital a financial institution is going to lose if there's a major downturn. So this it's not good or bad because you could be a perfectly good guy, that it's simply extremely tail dependent to adverse market movements. So of course, from a policy point of view, depending on whether you're good or bad, you may have different kind of policy strategies. And that, to be honest, I wouldn't know how to handle. And to finish answering your question, I think, if you look at the level of systemic risk measured by these indices or other indices, that try to kind of attempt to estimate the downtown losses conditional on extreme states of the economy, what you see is that there are instances in which these indices spike a lot, but then nothing happens. So typically what we observe, and this is also why the predictive power in a way is kind of not as strong as you would hope, because there are periods in which you might have high vulnerability, but if you don't have a triggering events, high vulnerability, it's not a problem. And in a way, firms need to take excess leverage, for instance, to make money, right? So absolutely, these are in a way weird predictions because they try to measure how things are going to go conditional on a trigger events that makes the whole system go bust, but that event might not always realize. And of course, there are kind of also complicated interrelationship with the macro system and yeah.
Thank you very much.
Thanks.